This physics review video is from Unit 7, Momentum. The topic is impulse. Impulse is similar to the relationship between work and energy, and we're dealing now with impulse and momentum. Impulse is the change in momentum. So if my momentum increases or decreases, that is directly as a result of an impulse from some other object. Another way of saying it is applying an impulse changes the momentum on an object. So what can cause an impulse? Two things impact how big the impulse will be. One is the strength of a force. So I need to apply a force in order to change the momentum. And also the amount of time that I'm applying that force for. The longer the time, the greater the impulse. So our equation for impulse is force times time. Again, we want to be able to shorten this so it's easier for us to use. So instead of using capital I, which we can't use, that stands for the moment of inertia, we have to use the letter J for impulse. So J equals force times time. When we deal with units for impulse, we have to know that we have to be able to add and subtract momentum and impulse. So I have to think about that. So for force, I use the Newton, and for time, I use the second. So the unit for joule is the Newton second. Now Newton second doesn't seem as if it's the same as the kilogram meter per second that we learned about in the last video about momentum. But in reality, the Newton is actually the kilogram meter per second squared times a second. What happens is one of the seconds cancels out, and I get the same thing. Here I've got a rocket ship that is going at has a momentum, of 400 kilogram meters per second. It then, because of its boosters, increases that momentum to 1,500 kilogram meters per second. So its momentum increased. I know that has to be because of an impulse. The impulse is a force for a certain amount of time. So if I'm solving for an impulse, it's equal to the change in momentum. My momentum changed by 1,500 minus 400 kilogram meters per second. So in this case, my impulse is 1,100 kilogram meters per second, or Newton second, whichever you prefer. So I can just subtract to find my impulse. Or I can use my equation with a force and a time to find my impulse. In this case, I'm solving for impulse. The force is 100 newtons, and the time is 15 seconds. When I multiply 100 newtons times 15 seconds, I end up with my 1,500 Newton seconds. That's the change in momentum and the impulse.